Hey guys, how's it going? So today we're continuing our ordinary differential equations process from last time. But this time, there's a special condition I want you to consider. I'm just going to do this problem first, and then I will continue on and explain. So we have y prime prime minus 3y prime plus 2y is equal to e to the power of 2t. So the first part, as I explained, is we pretend this is equal to 0. And yeah, r squared minus 3r plus 2 is 0. And r is 1 and r is 2. So based on that, it's the yc of t is equal to c1 e to the power of t plus c2 e to the power of 2t. All right, here's the second part. And this is where things get a little funny, but bear in mind with me. Okay, so notice that usually the particular solution would have been is equal to a e to the power of 2t. Usually this is the case. It's not in this case. And let me tell you why. You see this e to the power of 2t right here? Whenever there's a particular overlap, here's the general case. You multiply something. I'm gonna write the general formula here. It's ypt is equal to original. So this a e to the power of 2t would be original. Original this thing can be a real pain in the ass sometimes. Okay, original times t to the power of n. And the number n is equal to how many times the characteristic equation contains an r value or a root equal to the particular solution. So here, e to the power 2t, you see it's once. So you multiply it by t. N is 1 in this case because there's an overlap here. So because the characteristic equation contains 2t and here's 2t. So you multiply it by t once. So yp of t is at e2t. And now we're going to derive like usual. So y prime p of t is equal to ae2t plus 2at e to the power of 2t. Yeah, right? A to the power of e to the power of 2t, and then at. Yeah, okay. And then y prime prime E of t would equal, okay, so that's 2a e to the power of 2t plus, and 2a e to the power of 2t. Okay, so that's 2a, yeah, that's still 2a e to the power of 2t. E to the power of 2t plus 4at e to the power of 2t. 2t, and that's 4a e to the power of 2t plus 4at e to the power of 2t. Okay, now we can go down here. Y prime prime, 4a e to the power of 2t e to the power of 2t. Okay, minus 3y prime, so minus 3a e to the power of 2t. Plus, okay, so minus 6 at e to the power of 2t. Okay, and then ypt plus at e to the power of 2t. Power of 2t. I almost forgot the 2, but I remembered. And that's simply equal to e to the power of 2t. Okay, these will cancel out 2at e to the power of 2t, or at e to the power of 2t, the power of 2t. Just a little cool note before I continue on. Whenever you have this, notice how at doesn't fit anywhere here, and then like I kind of like knew it off my head, but like I see a and at, I had a feeling the t's would cancel out, but if you don't really have that foresight, don't worry about it. So 4a minus 3a is 1. So that means a equals 1, implying that ypt is t e to the power of 2t. Okay. So y of t is the yct plus ypt will simply equal c1 e to the power of t plus c2 e to the power of 2t plus t e to the power of 2t. And there you go. That's the trick whenever you see overlaps. It's just multiply the original particular solution by how many times the root is in there that it has. And that is it. So if you do one more example, I won't do the whole thing. So if you had something like y prime prime minus 8 y prime. This thing could be a real pain sometimes. Plus 16y equals t e to the 4t. I'm not going to do the whole thing, but it's pretty obvious that r is equal to 4. And then your original t, so y p or ridge short for original, would equal a t plus b e to the power of 4t. But then you're supposed to multiply by t squared because r is 4, it's a double root and it's 2 times in here. So you have to multiply by t squared. So yp equals t squared times this, which is equal to at cubed plus bt squared e to the power of 4t. So there you go. These are what you need to do in special cases. That's it for now. I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.